Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. In the last lecture, we did two questions of exercise of Unit 6, which is work, power, and energy. Today, we are going to discuss the third question, which is on page number 95 of the book, and in first part they are saying define number one potential energy and number two kinetic energy. We did this in the previous lectures. You can go there and check it, but for your memory refreshment, I am revising it. What is kinetic energy? The energy possessed by a body by virtue of its motion is called kinetic energy. And you know, kinetic energy is equal to 1 over 2 mv square, where m is the mass and v is the velocity. Similarly, potential energy is that type of energy which is possessed by a body by virtue of its height or configuration. And you know, potential energy is equal to mgh, where m is the mass of the body, g is the uh, gravitational acceleration, which is equal to 10 m meter per second square, and h is the height. Okay, that was the first part. Now in b part, there is a numerical type of question which is saying a 2 kilogram object is released from rest. So m is equal to 2 kilogram. M is equal to 2 kilogram. We are writing the data as we are going ahead. Release from the from rest from a height of 10 meter. So here h is equal to 10 meter. And now they are asking us, above the ground, calculate the initial potential energy at the moment of release. So we have to find potential energy, and you know, potential energy is equal to mgh. So we have to put the values. All the values are available. M is 2, G is universal constant, and H is given as uh, 10. So when we multiply all these values, so for example, this is the initial point, and there is above the ground, that is 10 meter. Remember this. So at that release point, the height is 10 meter, and there is an object of 2 kilogram. So remember my these words, that there is 2 kilogram of object. Okay, ladies and gentlemen, I made this because there is a need in the second part for the explanation. The second part is saying the kinetic energy at the moment it reaches 4 meter above the ground. Now this is 10 meter, this is the middle, so 4 meter will be approximately here. So what will be the kinetic energy? We cannot find kinetic energy directly because we don't have the value of V. So we have to find potential energy at 4 meter height is equal to mgh. M in this case is again 2, G is 10, and here we are having 4 is the height. So when we multiply it, it will be 80 joule. But this is not the answer because we have to find this. So we have to subtract this from the whole. So we will write this, that potential energy at height uh, 4 meter is equal to 200 minus 80 joule. So when we calculate it, it will be 120 joule, because this is 4 and this is whole 10, so we have to subtract this, and from above it is coming. So this much potential energy will be converted into kinetic energy. So you have to say that kinetic energy at the height 4 meter above the ground. So ladies and gentlemen, this is the answer of the second part. Now the third part is saying the speed of the object just before impact with the ground. So here we have to say that kinetic energy will be equal to potential energy. Whatever potential energy was at this point and before the impact, all the potential energy will be converted into kinetic energy. So we are going to find kinetic energy at the impact point. Uh, 1 over 2 mv square is equal to mgh. So this m will be cancelled with this one, and when we make this velocity as the subject, so m g h, not m is cancelled, so 2gh, I have to write 2gh, and then we have to take under root for this square removal. So putting these values, v is equal to 2 into 10 into 10 under the root. So it will be 14.1 meter per second when we solve this question. Okay, ladies and gentlemen, there is another small question at the end of this page. They are saying after the impact, when it hit the ground, that is called impact point. After touching, the object finally comes to rest. Explain what happened to the lost kinetic energy. So it means that at height the object was having potential energy, and as it was coming down, then before the impact, all the potential energy will be having maximum kinetic energy, and when it touch the ground, so it will change into two energies. One is sound and the second one is heat energy, which is also called internal energy of an object. So it will be converted into sound energy, because when it hit the ground we will hear a sound, so it will be dissipated in the surroundings. And when we touch this object, if it is touching, this is also metal and this is also, so it will produce heat. So it will be converted into heat energy. So that was also a small part. Now, ladies and gentlemen, we are going to discuss. There is question number 4, and in question number 4, there are fill in the blanks. This is a very long uh, question. The answer is short, but if you are having book, pay attention. Fill in the blanks in the following paragraph. Whenever there is given an empty space, I will say that here is the empty space. When a man knocks a nail into a wooden block with a hammer, store dash energy. I told you stored chemical energy. In this first dash, there will be chemical energy. In his body is used to do work in lifting up the hammer in its raised position. When there is a height, there will be gravitational potential energy possesses dash energy. Dash means empty space. So in the second one, there will be in rest position, and that will be gravitational potential energy. Further, when the hammer falls, the dash energy, the gravitational potential energy is converted into dash energy, kinetic energy of the moving hammer. When there is a movement, then there will be kinetic energy. This kinetic energy, this dash energy, means that this kinetic energy is then used to do work in driving the nail into the wood with the dissipation of dash energy, that is sound energy, into the air, and the production of internal energy, heat energy, in the production of dash energy, in the production of internal energy. I told you you can write heat energy as well in the block, nail, and hammer. So these were the uh, empty spaces, and we filled that with the appropriate type of energy. Uh, B part, describe qualitatively the term efficiency as applied to a power station, which converts the input energy in the form of fuels into useful output energy in the form of electricity. Ladies and gentlemen, when there is electricity generating stations, and if you visit that place, then you will see that either coal or nuclear energy is used to produce input energy for rotating a big turbine. In the hydroelectric power, water is considered, the following water will have potential energy, and that potential energy is used to rotate the turbine through the belt. It is connected to the internal system, which is creating electrical energy. But in case of heat energy in the form of coal, which we will call as input energy, there will be a heat production in that, and heat is a form of energy, and that input energy will be used to rotate the turbine, and then it will be connected to the generator, and the generator will produce the electricity. So that was the whole story about the B part. Question number 5 is saying in A part, define the what. We define the what What is the unit of power? SI unit. In British engineering system, horsepower is the unit of power, but SI unit of power is what? When 1 joule of work is done in 1 second, then the power dissipated is known as 1 watt. We did this for your memory refreshment. I did it again. What is meant by power? Work done per unit time is called power. Work done per unit time is called power. If a person is powerful, he will do work efficiently, quickly. But if a person is lazy, he will not be that much efficient. He will do the same work in more time. So the first person will be considered as a powerful person, and the second will be a weak person. We did these things in the lecture theoretical portion, so you can go and check that. Okay, there is a question number 5, and in question number 5 they given us a diagram, and this is the C part. Question number 5, and that is the C part. There is a car which is moving on an inclined plane up to the tabletop. The table is 0.6 meter above the floor, and there is a string connected to the front part of the dummy car. So a person is dragging it, and the length of this inclined plane is 1.2 meter. This is the whole story given to us, and now listen the question. Ladies and gentlemen, this is the 6 number question. We will talk about this in a moment. But first we are going to do C part of the question number 5. Question number 5, C part. And that part is saying that in the following situations, calculate the power involved. So we have to find the power. And then they given us number 1, a force of 50 Newton move through a distance of 10 meter. So F is equal to 10 Newton, and distance is given as through a distance of 10. This is 50 Newton. This is 50 Newton and a distance of 10 meter, and time is also given to us as 5 seconds. Time is given to us as 5 seconds. So ladies and gentlemen, as we know that power is equal to W divided by T. Here we don't have the W, but for W we are given the data which is F cross D. F is 50 and D is 10. So it means that uh, work done is 500 joule. Now we will put this value inside this. So P is equal to 500 and the time is given as 5. So when we divide 500 by 5, so it will give you 100 joule. And that, sorry, watt, not joule. That is the watt. So 100 watt will be the power, and that is part number 1. In the second case, they are telling us an object of mass 1 kilogram. An object of mass, this is second part we are doing, 1 kilogram. An object of 1 kilogram is lifted up vertically through 5 meter. So M is equal to 5 meter. M is given as in 10 seconds and time is given as 10 seconds. Ladies and gentlemen, we have to find power in both cases. In the first case, we found it 100 watt. Now, in second case, we will use this data and we will find the value. So, here P is equal to work done divided by T as in this case. But here work is in the form of potential energy. So we have to write instead of W, mgh. And M is given as 1 kilogram, G is universal constant, and H is 5 meter and T is 10 seconds. So it means that it will be 5 watt in this case. Okay, now I explain this again. I am explaining it that in question number 6, they are saying there is no C part in the question number 6 directly. There is, this scenario is given. There is a table which is 0.6 meter above. There is a car connected with a string. A person is dragging it to the top of the table, and the distance of inclined plane is 1.2 meter. And this is the floor. This is the scenario. Now let us understand the question. A model car of mass 1.5 kilogram, 1 point mass is equal to 1.5 kilogram. With a string attached to its upper end is placed on a slope as shown in the diagram. The force in the string parallel to the slope. This is parallel to the slope. The string is parallel to the slope. Needed to move the car up the slope at a constant velocity is 10 Newton. So F is equal to 10 Newton. Here F is equal to 10 Newton. G we know is equal to 10 meter per second square is the universal constant. And in this scenario, we also been given height is equal to 0.6 meter. Now, in the first part of this scenario, they are asking us describe with the aid of a diagram how the force in the string can be measured. Ladies and gentlemen, if I am drawing the diagram for this car here, so there is a string which is dragging, so the person will do work against the force of gravity which will be downward, and there will be, because there is F, we have to find, so mg, because there is a gravity which will be downward, and mass is given as 1.5, and then g is given as 10, which is universal constant. So it means that 15 Newton force will be applied, but they are not asking to calculate it. They are just telling us that how force in the string will be calculated. So string, there will be, when you are dragging it, there will be force in this direction, and tension in the string will be in the opposite direction. So if you found the tension in the string, it will be equal to the force applied on the string. So this was the first part explanation. They actually don't want us to find, yeah, calculate it with the help of the diagram, but they are wanting us to find it in the. Now the second part of this is saying that the second part of this question, calculate the gain in the car's potential energy as it moves from the floor to the table. You have to find the potential energy in this case. And ladies and gentlemen, you know that potential energy is equal to mgh. M is given as 1.5, G is constant, H is 0.6. So when we calculate it, it will be 9 joule. It will be now 9 joule will be the final value. Okay, now the third part is saying that here I am coming and I am writing the data for it. They are saying calculate the work done by the force as it moves the car up the slope from the floor to the table top. Okay, so in this case W is equal to F cross D. F is given as 10 and D is 1.2. D is 1.2 meter. So it is calculated as 12 joule. Now the fourth and the final part of this question is saying calculate the efficiency. Calculate the efficiency of the arrangement for raising the car. Yes, efficiency we know is equal to efficiency is equal to output, useful output divided by input multiplied by 100%. Now we calculate in the first part 9 and then the second part 12. So 9 divided by 12 multiplied by 100%. When we calculate it, it will be 75%. So 75% is the answer. Ladies and gentlemen, I am leaving this question, that is the final, not the final. There is a 7 number question as well, and 8 number question I am leaving it for tomorrow. uh, that's it for today. Thank you for watching. Allah Hafiz.